everybody. This is Ellen Weatherford. I'm here, as usual, with just the zoo of us. This is an animal review podcast, and this week we're talking to a new friend about some really cool animals. This is Dr. Christopher Ma. Say hi.
Hello, how are you today?
I'm great. How are you doing?
Good. I'm just enjoying a fine Saturday afternoon here in Washington, D.C.
I'm really excited to talk to you. I'm excited to talk about our animal, but before we talk about our animal today, why don't you introduce us to you a little bit? Tell us how you got into your work.
Certainly. So I work on sea stars or starfishes, and I'm a scientist at the National Museum of Natural History, and that's at the Smithsonian here in Washington, D.C. I am originally from California. I am a San Francisco native. I'm Chinese American, and I grew up there around the California Academy of Sciences and around all the natural beaches and ponds and wonderful areas in the California region. And at a certain point, my dad got me interested in biology, and I started going to intertidal zones. And before you know it, I was doing internships at museums and taking a lot of interest in sort of weird animals like sea stars and worms and things like that. I used to collect bugs from the backyard. I eventually began volunteering at the museum in San Francisco at the California Academy of Sciences. After I graduated from high school, I went on to Humboldt State University, where I furthered my degree in invertebrate zoology, coming back to San Francisco for my master's, and then taking a very odd shift in paleontology to the University of Illinois in Urbana-Champaign, where I studied sea stars under a paleontologist. So yes, I studied sea stars, a marine animal, an animal that lives only in ocean environments in the Midwest, but a very good place to learn for staying focused on your interested topic. And eventually I have a research position. I'm an associate at the Smithsonian. I'm one of the world's specialists on sea star, what's called taxonomy and systematics. That is, I describe new species. I work on their biology. I'm also a frequent collaborator or associate with the Okeanos Explorer program. And that's a live stream deep sea biology stream that NOAA operates when they deploy their research vessel. That's a platform that operates at sea, but it beams or streams their deep sea research back to people on land. As such, I can call in and just offer them identifications or background history or information on many different types of sea stars and their relatives, as well as other marine animals. There's a lot of stuff that I do that is out there, and so I used to more regularly write a blog called the Echina blog, and I'm the author of many papers. And one of the things that I do primarily is describe new species. I search out and try to document the biodiversity of life on Earth in terms of sea stars. And so I've described something like 60 new species of sea stars, including a new family and several new genera, mostly deep sea things. I work a lot with biologists that collect specimens and work with deep sea ecology. I'm a veteran of many deep sea cruises. And in fact, Okeanos Explorer had me out there for a month. And that was a lot of fun. Do it again in an instant. But I've also been to Antarctica. I've done numerous ship tours in different places, but I do mostly museum work. A lot of my research focuses on museum collections, which is where a lot of diversity is actually kept. So when people go on expeditions, they collect specimens and bring them back preserved. And then I go through those collections and I can recognize and identify new species, often from preserved specimens. In that sense, I'll go to some place like the museum in Paris, and I'll spend a month there and come back with dozens of new species that had been previously unknown. And so it's within sort of my professional training. Some people have even said it's one of my superpowers that I can describe new species. I'm one of those people that, if you count when they say in the books there are 1,900 new species, I can describe another one and say, oh, that is now 1,901 new species, because I just did that. But the nice thing about the recent Okeanos cruises is that I've been able to not only look at the specimens after they've been collected, but I've been able to see them in their natural habitat alive and feeding and doing things, alive. But one of the things about what I do is that because you work on these animals as a species, one often has to sort of be a broad based scientist. You have to know a lot about everything. And the blog that I wrote helped me to develop a lot of familiarity with different parts of the animal's biology. So I know a little bit about everything. Some people would even say that a little bit about everything is a little dangerous, but I know a lot about not only just other echinoderms, which are the relatives of sea stars, including sea urchins and brittle stars, but also many other marine invertebrates that I just find interesting. So I try to really be sort of well-rounded as far as knowing a little bit about a lot of different weird marine animals. And some of that hails from my Saturday afternoons, very much like this one, watching what we used to have were traditional monster movies in the afternoon on television, and or perhaps and I'm still a huge Godzilla fan. So, and I started out as a student, much like anybody else, and I can't tell you how many times it would be a great surprise for me to go back and talk to that younger self and let him know where I am now, because I would never have thought of it that way.
That's so amazing. Like, first of all, the awesome journey that you've gone on. Like, even when I think of just like going to Antarctica or going out to see sea stars out where they live, that is very exciting to me. I feel like that's like a dream come true, right? Especially for a kid who is interested in marine biology. That's the goal, right? You're living the dream.
Yes, I'm not going to lie and say that those are a lot of cool things, and that I relished all of those. But I'll be honest and also say that field work is, as the word implies, it's work. And there are many days when, especially with long, sort of extended research cruises, where there is some adversity to be dealt with, and and there are times when it is downright, to be honest, it's a little scary. And I mean, it varies from just being challenging to just wanting to sleep in a nice bed every once in a while, because sometimes you have a very different experience in the field than you do. I mean, I've always been fairly comfortable relative to, in my years as a geologist, you do a lot of camping, and camping is fun too, but there are just days when you find yourself in very uncomfortable places, and that's part of the life. It's something that you can look back on later and kind of brag about, to be honest. But when you're doing it at that time, it's a challenge, and it's good to challenge yourself. So anyway, I understand that you have some questions from very interested young people.
I do. So our friend Libby Whitmore in Boulder, Colorado, sent us a very lovely email saying that their family had recently seen sea stars for the first time. I'm taking your cue, by the way, and calling them sea stars instead of starfish.
It honestly doesn't bother me which term you use, but I understand certainly that people who haven't yet gone through the whole gamut of zoological training, that sea stars is somewhat less confusing. So
I called them starfish today. So
fine.
just I'm picking up on sea stars from you. But the Whitmore family wanted to learn a little bit more about these cool friends. And I do too, because I'm not very familiar with them. I don't live in an area, I live in Florida, and so our beaches are not the type of place where you can go like rock pooling and tide pooling and stuff like that. I don't get to see sea stars very often. So you had mentioned that there are, all these different species of sea stars. Like, what does diversity look like among sea stars?
Oof. Well, so there are, as I'd said earlier, there are some 1,900 species. Well, it's more like 1,980 species. So we're coming up on 2,000. If I'm productive for the rest of my life, we'll get there. So, you can have sea stars most of them are 5 rayed. Some of them, like there's a species in Antarctica that can have up to 50 rays.
These are like the arms around the center of it?
Yeah.
Okay.
So some sea stars have sort of separate and elongate arms. Other sea stars are almost cookie-shaped. In fact, in the extreme case, there's one sea star that lives out in the tropical Pacific that is round like a ball. And and I'm not kidding. It's literally sort of golf ball shaped. And yet there are other sea stars that are flat, and so flat that they look like a piece of cloth laid on the sea bottom. There's a myriad of species. They occur in the deep sea. They occur almost anywhere there's ocean. the Antarctic, the Arctic, down to, in the intertidal. There are coral reef sea stars, obviously, sea stars that live on sandy bottoms, and sea stars that live at 6,000 meter depths. So there are a bunch of them and that live all around the world in the oceans in different habitats.
Would you find any of them in freshwater?
That's a good question. So sea stars and their relatives, the echinoderms, are only marine animals. That is, they only live in the oceans. This is a relatively short list of animals in general, and it makes them sort of unusual because, and this isn't a time perhaps to discuss the full ocean, freshwater, terrestrial evolution situation, but echinoderms, for whatever reason, have been very successful living in our world's oceans, but have never adapted to living in freshwater or terrestrial habitats the way that, say, crustaceans have or that mollusks have. And some people believe that's because of the way that they osmoregulate, which is to say how they can deal with water loss. And essentially that so much of echinoderm biology is tied to living in the ocean. Their body fluid is literally seawater, that perhaps it has just never worked out that way. And so there was a joke I did once on an April Fool's blog where I wrote a post about everything you ever wanted to know about echinoderms from freshwater and the land. And it was empty. It was blank until you get down to the bottom. And that's an old joke taken from a colleague who gave one of my other colleagues a book that was labeled Freshwater and Terrestrial Echinoderms, and it was an empty book. But that said, echinoderms do so many strange things that I don't think we'll find freshwater or terrestrial echinoderms, but it wouldn't surprise me if we started looking at other planets and we started seeing things like echinoderms in the oceans of Europa or something like that. And that's very speculative, but I think that the bizarre innovations that echinoderms have, and echinoderms have a number of really just downright, strange features for animals. That's why people are so enamored of them, is because they're just so bizarre. I mean, but for example, echinoderms have a 5-part symmetry, what's called pentameral or pentaradial symmetry. So the thing is, though, that they're not primarily symmetrical like that. They're actually, when they're larvae, when they're babies, they're bilaterally symmetrical like we are. They have a right and a left side. And then they a lot of them become flattened out and they become 5-part adults. And so sea stars, for example, will sometimes develop into, their adult symmetry after they've settled out onto the ground. And then on top of that, they will add arms in between. So some sea stars can have up, as I said earlier, 6 to up to, sometimes 20 or even 50 arms or rays. But there are so many more just echinoderms that do so many bizarre things, like how because they live like this in this kind of 5-part symmetry, the solutions they have to finding like food and other aspects of their biology are very different from like other animals. Like the 50-rayed sea star I mentioned earlier, most people don't realize that sea stars can actually capture mobile prey. This animal has its arms out into the water, and it has little sort of bear traps covering over the surface. And when krill get too close to the surface of these arms, they're caught by these little bear traps, and the arms grab them and pull them down and eat them alive. They're easily like a foot or two across. So, and there are other sea stars that actually feed this way. A lot of people don't realize that sea stars, and granted, these are exceptions, but there are a fair number of sea stars that can actually feed on moving prey or mobile prey. There's one sea star in New Zealand, for example, that will sort of stand itself up on tippy toes, and it'll pretend to be a cave, and it waits for little shrimp. And when little shrimp go in between the little spaces, it slowly lowers itself on top of it and drops its stomach onto that, and boom.
That's diabolical.
That's downright strange, But all echinoderms, all animals related to sea stars, have bizarre biology or, sometimes other dynamics of their life cycle are very unusual. And so that makes them a big fan for marine biologists who want to study them. And paleontologists as well, because echinoderms have been around longer than dinosaurs. They have a fossil record which is really rich that extends all the way back to the Paleozoic, which is some 500 to 600 million years ago. And sea stars, modern sea stars, were around probably before dinosaurs. So, in spite of all these very interesting sort of adaptations and body plans, they actually have a very stable sort of body plan, a successful shape that has gotten them through a lot of hard times when you think about the history of the Earth and its oceans. And this continues to be the case, where they're a lot of times considered to be barometers or canaries in a coal mine, so to speak, relative to climate change. They react to a lot of the changes in the ocean chemistry as the climate has been changing. So they're a very important species as far as the oceans go.
Oh yeah, I'm really excited to dive into some of these weird adaptations because so if this is anyone's first time listening, we review animals and rate them in different categories. So our first category that we rate animals on is effectiveness, and this is physical adaptations, things built into the body to make the animals do a really good job, right? So this is what you're talking about, that stable body plan, bear traps on their skin. That definitely counts. So out of 10, what would you give them for effectiveness?
I'm going to go in a big 9 or 10 range with these because they do so much with essentially so little, or at least in such an alien way that maybe not 10, but 9 to the E or something strange.
An A plus.
Yeah, because they don't solve the solutions in the same way. A lot of sea stars, I mean, there are certain limitations. Like I said, they don't do well in fresh water. And you can see in certain places following a storm where there's lots of freshwater runoff where sea stars have died en masse because freshwater can be toxic to them. And you've told me you live in Florida, and along the shores, after a big storm, there are often hundreds, if not thousands, of sea stars that get washed up, sometimes due to the freshwater input, and sometimes because of the waves. But if you look at, how effective they are in their natural habitats and what, how they've solved a lot of the solutions to living in their habitats, in their natural settings, there's a lot of really impressive relationships and stories there. But for example, you have a lot of those same sea stars that I was talking about that get washed up. They live on sandy bottoms. There are certain species of sea stars which live off the coast of Florida on sort of sandy bottoms, and they dig into the sandy bottoms, and they can live sort of buried below the surface. And they do so with little pointed tube feet, and they have little spines around the edge of their body, which also they're jointed, and they can actually sort of move like little shovels. And you can put one of these, there's a number of videos of different sea stars doing this in time lapse, but even watching them doing it in real time is pretty quick. But they can essentially, watching these bury themselves into sand is just remarkable because they just vanish. Sometimes you'll see a star-shaped impression, but watching them just bury themselves into the substrate, whether it's sand or mud, is just really amazing because they do so very quickly. And they live sort of just buried below all of the sediment, and they go hunting for clams and other things. And you can sometimes find them when we collect them on scientific surveys. You can find their bellies are filled with clams and snails and things. And so some of these sea stars, one of the oddball things about them is that even though they're kind of proper animals, they don't have an anus. They don't have a place where they can go pooping. And so they have to eat all of the things they're going to eat, and then they have to spit all the shells out through their mouth. Sometimes you can find, there's a giant sea star that lives in the Pacific, and sometimes you'll see them having swallowed a large sand dollar or something that is the size of a small tea plate or something. And it'll digest it for a while, and then it has to kick that out of its body eventually. And what's remarkable about that is that they have this bizarre skeletal system, sort of a connective tissue system called catch connective tissue. So the sea stars and all echinoderms are basically I don't know if your listeners may be familiar with three-dimensional puzzles. But for a while, those were really popular because they were just like these 1,000-piece puzzles that you could build in different directions. They're like three-dimensional boxes made up of thousands of little pieces. That's exactly how a lot of echinoderms are, is they're just lots of bone pieces held together with connective tissue. And so they can literally open up a lot. They can change the tension or the strength of their connective tissue such that different parts of their body can bend more flexibly or inflexibly or just outright open. So some sea stars can swallow something that seems much larger than you think that it would be sensibly able to, and then open the rest of its body to release it. So a sea star might swallow a sand dollar that is twice its size, and it looks like a cartoon. It looks like, you see this big bulge coming out of the disc, and you think maybe that sea star has swallowed more than it can handle. But in truth, it probably will be able to just sort of flex open its mouth and get that out eventually. And so, that's what I mean by extraordinary adaptations, and their solutions are a little unorthodox, but like even predation, for example, they're very effective predators. And some sea stars are actually predatory specifically on other sea stars. And there is this bizarre dance, sort of almost like wrestling, that happens. There's a sea star in the North Pacific called Solaster, a sun star, and these can actually move over their prey item like another sea star. And there's a great paper from the 1970s or 60s rather, where it describes this in fairly colorful terms. And it has this behavior of what's called the 18-arm hammerlock. It's a multi-arm sea star. It has about 16 to 18 arms. And they will move over other sea stars, and they will physically trap them. So they'll move over and they'll sort of wrestle them down, and they'll begin to swallow them sort of arm by arm. And the response of other sea stars to this animal is so sort of severe that they can smell them coming in the water and will move away from them immediately. And there's another big predator, something called a sunflower star, which is almost sometimes 2 feet across. Almost always they're larger than sun stars. And if you can literally take a sun star that is the 10th of a size of a big sunflower star and put it right on one of the arms, and you'll see this little tiny sea star cause this giant starfish to gallop away in fear, because the reaction is so ingrained, and the relationships are so close, in terms of their behavior and so forth. There are a lot of stories like that, of just so many interesting ways that sea stars have adapted to where they live and how they feed.
I was going to ask, because you were talking about their efficiency as predators, which I think if you're not very familiar with sea stars, you probably don't associate sea stars with predatory,
Oh,
they don't seem very threatening to you. But I'm wondering, because I'm thinking of what I know about a sea star. I don't have any concept of where they would have eyes, ears, mouth. How are they like perceiving the world, right? Like, do they have eyes? Do they have ears? Like, what's going on?
Good question. So I should also just back up just a moment and say that, like, a lot of people think of sea stars as almost being kind of immobile because they don't move very quickly. The thing is that they move in almost a different time frame than we do, because they're very slow. So relative to the way we perceive time, but if you watch them with time lapse, they're actually very complicated and they move quite effectively. And they just do so, in a very different time frame. And if you look at intertidal zones, sea stars are all over mussels. And in fact, a lot of times sea stars are what's called keystone species, which some people and the ecologists endlessly debate over what this means. But effectively, it means that sea stars are always huge influencers of the types of animals that live around them, because they usually eat them. And so, like on an intertidal zone, sea stars feed on a lot of the mussels and clams and things, and they keep a lot of those mussels and clams at a particular sort of community structure and shape. So they're important. But onto your question about how they detect all of these things around them, I had mentioned earlier that sea stars, the circulatory fluid of most sea stars is ocean water. And so they're very closely attuned to a lot of the sensations around them. So effectively, they can smell a lot of what's around them. They have very strong chemosensory senses. And so, as I had mentioned earlier, sea stars can smell other sea stars, but also they can pick up on odors in the water of food. So I've done plenty of aquarium type experiences where you have a bunch of sea stars and you drop a whole bunch of krill or dead shrimp or food into the water, And even if none of them are in contact, they can smell all of that in the water right away. And you'll see all of them, I dare say, galloping towards where the food is. And they can pick up on some on detection of light. They can feel things. They I think to a certain extent feel their way around. I've often seen sea stars right at the water's edge in aquaria, where I think they're kind of sort of literally reaching for the sky. They're sort of testing and trying to feel what the water tension is like at the edge. But sort of more conventionally, it's from detecting sort of the smells, if you will, from the water. But also, remarkably, sea stars have eyes, or some species have eye spots. And so these would be located on the tips of each arm. So this varies according to different species. Species which live in the deep, deep sea where there's no light have very poorly developed to absent eyes. But the ones that live in shallow water where there's lots of light and whatnot, some recent science has actually shown that not only do some sea stars have the ability to detect light, but some of them may actually have the ability to determine images. So just like a lot of vertebrates, they can actually sort of make out shapes. It's difficult to say exactly how well resolved these images are, but recent papers by some of the labs in Europe have shown that there are certain sea star species, like the crown of thorns sea star, which has about 15 arms. A lot of these can actually make out coral when they're moving around on the sea bottom, on the coral bottoms. And other similar species that live in those areas can do so as well. And then that's one of the things about sea stars that historically people have always been a little confused by, because they look so simple. They appear to almost be kind of, for a long time, people assumed they were kind of primitive animals that didn't have a lot of senses, because they're, like I said, they're very unusual, because a lot of what humans associate with intelligence is a brain, right? And the thing is that sea stars, similar in overall shape and morphology, their body shape, to something like jellyfish, is they're radial. They don't have a centralized place where all of their nerves meet and form this large bulb of ganglia. There's no brains. But surprisingly, echinoderms have a lot of complicated behavior, and they have what's called a radial nerve net. And the nerve net meets in a whole bunch of different places. They overlap and cross and join together in sort of, if you think about any kind of net, the net crosses in a whole bunch of places. And so the properties of this kind of nervous system are not as well explored, I think, as we would like them to be, but they definitely appear to be part of the reason why sea stars are much more complicated than people give them credit. Behaviorally, for example, I mentioned earlier that we can apply time-lapse video to sea stars, and it turns out that they actually have behavior comparable to the way that savanna mammals behave. We saw this in shallow water species and in some deep water species, but basically, if you have a large, like, dead carcass, this was something that they did as an experiment in the North Pacific years ago, is they left a big dead fish, or I think it was a sea urchin, and a bunch of bat stars sort of started to group around it. And one big one jumps on top, and it actually pushes away smaller bat stars because it's asserted dominance over the sort of the food. And in fact, even in the deep sea, in a recent observation we made on sponge feeding with the Okeanos Explorer, there was a large sponge that was being fed on by a whole bunch of sea stars. And these were, I think they go by the common name, anywhere from cookie stars to ravioli stars, but it's Plinthaster dentatus. And essentially, the biggest one climbs to the top, and the others kind of feed on the sponge sort of around the bottom, but the big one pushes the others off of it. So, at least that's the way I interpreted the imagery that we saw. There's a lot of time-lapse video the BBC has taken of very similar behavior where sea stars will just, even though it looks random, there is actually sort of a direction and a pattern to it. And the BBC has a really wonderful video of a whole bunch of Antarctic sea stars feeding on a dead seal. And it's got a very much the same kind of sort of interesting behavior pattern. So, to me, that's why we're always looking at echinoderms for a good 10. And like I said, I haven't even touched on what other echinoderms do, which is which is oftentimes just as interesting.
So first of all, I didn't think social hierarchy was going to come up. With them moving so slowly, they're preying on other things, but I know there's also things that prey on them, right? Like
Correct.
Other things will eat sea stars. What kind of defenses do they have against these predators? Like what do they have that helps them not get eaten?
That's a good question. It's not understood for every species, but a lot of sea stars are protected by the fact that a lot of sea stars have what's called saponins, which are a kind of chemical that a lot of fishes and other types of vertebrates find offensive. And as when they're larvae, there have been studies that show that they've tried to feed larvae to fishes, and the fishes will avoid eating them because they leave a bad taste in their mouth. There are a lot of sea stars that have what appear to be straightforward defenses like spines. The crown of thorns sea star in the tropical Pacific has really sharp spines that are actually, I think they're, what's the word? It's venomous, and you can get a nasty sting from them. But other sea stars have spines that are more blunt, but they have heavy armor development. So a lot of fish and whatnot might take shots at them, but they really don't get much other than kind of gritty sort of calcite. So the bodies of these things are made of chalk, calcium carbonate. And so they have big cone-like spines that reject predatory behavior. Things that do eat sea stars, though, are crustaceans. There's a horrible little shrimp, which is actually really pretty looking. It's called a harlequin shrimp. And even I can't deny the fact that they're gorgeous looking animals. But they're horrible to sea stars because they're often paired. There's a male and a female, and they will go around and they will find some poor sea star and just chop it up. They'll use their claws to just take off chunks of them in pieces and eat them up, one by one. But for example, when you get into the coral reef system, there's a whole complicated interaction with multiple animals involved because some of these crown of thorns sea stars, there's enough of them that they can provide an easy food for a lot of different species. But because they attack coral, there are a whole bunch of coral associates that actually react back to them. And so you have these complicated interactions where, for example, some of the shrimp, not necessarily the harlequin shrimp, but some of the shrimp will attack and open up wounds inside these sea stars. And then there are actually worms that will attack and go into them and try to attack the crown of thorns sea stars. And there are actually places where there are small crabs that live in corals that will bite the tube feet of crown of thorns sea stars to sort of fend off the attack, because that's where those little crabs live. And there's a lot of different interactions. And that's one of the reasons why sea stars are so important, is because love or hate them, they have a really important role in the interactions in a marine ecosystem. Sometimes they're prey and sometimes they're predators. Most of the time they're predators. And this changes for different kinds of ecosystems. For example, in the deep, deep sea, one of the animals I love to study are brassingids, which are deep sea stars. And these are unusual animals that have multiple arms, anywhere from 6 to 20. And the thing about them that is so weird is that their arms are elongate and bony, and there's no meat in them, and they're extended up into the water, and they have spines that they can use they have a kind of Velcro on the surface of these spines, and they can use them to capture small crustaceans. So the water current will bring these small animals, and they'll get caught on the spines, and then the brassingids will use their tube feet to move the prey down to the mouth. We see a lot of brassingids in turn with arms that are regenerating. And so it's possible that these are broken accidentally, but we've seen fish attack them. And depending on where these brassingids live, sometimes other sea stars or other predators attack them, especially at these deep depths where food is a scarcity. Some of these sea stars might actually, even though they're preying on other animals, everything down there is prey for something else. Because there is some food, there's very little meat on them, but there is some tissue to be had. But even though they're generally known as sort of very big predator type or sort of scavenger type animals, they do occupy, that circle of life type of thing. So
I was thinking when you mentioned that these types of sea stars can regenerate their arms to some degree. This is something I have heard about sea stars before. Can all sea stars grow their arms back?
So regeneration is a common feature of echinoderms and sea stars in particular, but the extent to which sea stars can regenerate is a variable characteristic. So, for example, most sea stars can regenerate an arm. Most sea stars, if the disc is intact, it will be able to regrow an arm, and that can take anywhere from weeks to months. And there are some sea stars that are kind of the superstars of regeneration. Some animals in the family of Phydiastridae, for example, or in the family Asterinidae, these are tropical sea stars. And for example, some of them can actually regenerate a whole, you can chop the animal in half, and instead of two halves of a dead sea star, you actually get two sea stars. There are some sea stars that are in coral reef aquaria that are kind of pests, actually. I think the genus is Achilonastra. And the reason that they become pests is because they come in on living rock, and they are actually what's called fissiparous, which is a long word for meaning that they can divide asexually. They can just walk apart from themselves and become two animals. So getting one of these animals into your aquarium means that they don't just double, they become exponentially more numerous in your tank right away. And they're kind of useful because they feed on algae, but they get everywhere. But I've seen them on the coral reef exhibit at the Smithsonian, you can see them on the glass. Sometimes they will just literally be caught in the middle of dividing and then dividing again. And a lot of people in the aquarium trade know that these exist. And so they're kind of benign, but not everybody likes having a jillion little sea stars running around their aquarium. And they're not necessarily deleterious, but like I said, after a while, they can be so numerous that they're difficult. They create difficulties for other things in the tank. There's another family, as I had mentioned earlier, the Ophidiastrids. These are more long-armed animals, and sometimes they'll just fragment, and you'll have an arm with part of the disc there, and that arm will regrow a whole new animal. That's often referred to as a comet. And so you'll see a lot of different sort of variations on the different species having different abilities of regeneration. But like in the extreme case, if you go into the deep sea where energy isn't really high, and something happens to a sea star, that's it. It doesn't really have a lot of choices as far as what happens, if it's attacked by something and half of it is devoured or something. But like as I said, some Brisingids, their strategy is to have like 15 or 16 arms, and then one or two of them can be lost, and they'll regrow that in a matter of weeks or so, or months. It's not entirely clear, but the whole story about how fishermen used to pull up sea stars and cut them in half, and then inadvertently they end up doubling or creating more sea stars. There's some truth to that, but it sort of depends on which sea star they actually pick up and how much and where of the sea star they actually cut, because the disc is usually the imperative part of the animal that it requires in order to regenerate most of the body.
Sure, it's like the Pokemon Staryu and Starmie, where like part of their like lore in the game is that if any of the segments are removed, as long as the big shiny gem in the middle is still there, like it can still come back.
Okay. Well, sure. I'm not as familiar with Pokemon as some, but I would say that that's probably not a coincidence.
Yeah, I know there's a lot of like actual zoology that has played into some. Sure. I think there's actually a Crown of Thorns Pokemon.
Oh,
it's a newer one. It's called Marini.
Oh, okay.
And it does have that kind of like tent shape almost.
Oh, interesting.
It's really cool.
Yeah. Well, I can send you this blog that I wrote, but one of the things I'm a big fan of anime and Japanese pop culture. And one of the things that is sort of adjacent to that is the fact that the Japanese are really big into natural history. It has a much more solid place in their culture because I think they're an island nation and there's so much about them that people encounter on a regular basis. But, there are lots of very serious citizen scientists in Japan. Even toys are made out of starfishes. popular, mainstream toys that are made. I mean, there was this was one of the more bizarre things to happen to me, but a few years ago, I was in Japan, and it turns out that a starfish that I described in 2002 got made into what's called a gashapon, a candy toy. I wasn't collaborating with them. I didn't know them, but I just suddenly saw this species I described, and it's really distinctive because it's orange and it's the shape of a pumpkin, and it's a long story. I'll send you the link, but essentially it showed up as this toy, and I was like, wow. So now I own as many of these as I can find, but it's sort of like, no, I mean, I didn't get any for free, but it was just fascinating, because the species was described as part of this biodiversity book. And the company saw it and made it one of their figures, probably because it was big and orange, and it does actually occur in Japanese waters. So it's surreal seeing something that you described. It takes me years sometimes to describe a new species, and to have worked on that animal and then seeing it as a toy.
It's like the highest form of fan art.
Yeah, it is. I mean, short of actually seeing it changed into a Pokemon or something.
You never know. I would keep an eye out because there's about they're coming up on 1,000 of them bad boys. So I would probably not count it out.
I'm looking forward to it then. I was just talking to a friend of mine who works on polychaetes, on worms, and there was a recent comic published by DC where the artist had taken. There's these scale worms in Antarctica that they're formidable predators, and they have these big, terrifying jaws. And there's an artist who picked up on that and used it as a monster in one of their. And they're so distinctive that it's difficult not to see where the inspiration comes from. And it was just fascinating how well it was morphologically accurate, which was very kudos to the artist. But it was just fascinating to see how far we've come, how the internet has carried so many of these animals into sort of pop culture, or at least to a lot of people that would ordinarily never have known what any of these animals even were. Well, I talk about anything from sea pigs, which are sea cucumbers, to giant isopods. I mean, years ago, I saw a young lady on the bus who was wearing a pink giant isopod shirt. And I asked her, do you know what that is? And she's like, oh no, I just bought it because it looked cool.
Oh.
And I was like, wow, okay, but since then, you go on Twitter now, and thanks to these live streams and thanks to the popularization of a lot of deep sea animals, there are so many people now who can recognize Brisingid sea stars. There was a time when the word Brisingid sea star was something only uttered by specialists. I mean, there was literally maybe a dozen people in the world who use those words, ever. And now you can find them on Twitter.
Science communication, baby. That's how it goes.
Oh, I know. Well, that's why so many, there are a lot of people, administrators and so forth, who question the effectiveness of social media and education. And I'm like, I don't need to, as far as I'm concerned, this battle is over, because look at how many deep sea animals are household names now. I mean, not just the common names, but the scientific names, I mean, and we're not just talking about the weird fascination that kids have with dinosaurs. We're talking about, things like Pheronema, the little amphipod that attacks salps and hollows them out. There's people that love those things. The sea stars, giant isopods, the list goes on, sea pigs, the list goes on. There's a whole bunch of things that, well, like I said, if my 1998 self had come to the future and was looking, well, we didn't have the internet really back then either, and looked at what we have on the internet today as far as what is popular culture, he'd be really surprised. And and I admit, Brisingid sea star is not something that's going to be coming out of the mouth of some celebrity, but there are so many people on Twitter when we have an Okeanos live stream that now recognize Brisingids that I'm just flabbergasted. So
it's heartwarming.
Sure. Oh no, it is. It's just I'm just surprised because I literally was able to see a spike in sort of I was looking at Google the metrics for certain terms, and I looked at the term sea pig. So sea pigs are sea cucumbers that live in the deep sea. And there was one weekend when there was a simultaneous use of a sea pig on a Facebook quiz, but I saw it and I saw it sort of circulating around because my blog numbers were up for this one post I had with the term sea pig that mentions them offhandedly. But it was, I mean, it spiked like crazy. So I immediately picked up on the connection and I wrote a whole post about sea pigs. And there isn't a lot known about them, so it wasn't hard. But a few pictures later, and before I knew it, that was one of the highest watched posts I'd ever written up to that point. And it still is. And there's literally like this huge spike in Google hits on sea pig that's correlated with roughly that weekend. Was it just me? Was it the Facebook quiz? I'm going to take credit for it, but it like I said, it fascinates me how much has changed.
Yeah, it's very, I'm coming into this like doing this science communication project that is like pretty much all of our like audience growth and outreach is all done on social media,
Yeah.
But it has been incredibly effective. That's where people are hanging out, like if we're all scrolling through Twitter, might as well put your stuff out there on Twitter so that people are, it makes sense to try to reel it back in a little bit. Our next category that we review animals on is ingenuity. For us, this is behavioral adaptations that let an animal solve problems, or like you said, intelligence is hard to frame for an animal that doesn't have the same nervous system that we're thinking of. But this is basically just like behaviors, just things that they're doing with their body. What do you give sea stars for ingenuity?
I mean, well, like I had said earlier, I think a lot of the credit I give sea stars, which has to be a 10 or better yet, a 15, is because it's so unexpected. It's not so much that they have a real, they're not octopuses, but it is surprising how much complexity they have because of the assumptions that have been made about their nervous system and about their behavior before we had the technology to watch them. The behavioral complexity that we observe in sea stars now is largely the result of the fact that we can observe them in time lapse. And that really hasn't been done very much at all in research. There are lots of, now with the advent of social media and so many photographers who are doing, their own videography, we can see them. But the truth is that there's a lot of behavioral pattern that we just didn't see before, what used to be, because they're so slow. Again, slow is a word I use, but in truth, they operate in a different time frame. But for example, there used to be just pictures of sea stars on sandy bottoms. They look like they were just sitting around. But we would see a time-lapse video, and it turns out that a lot of these sea stars will march in a line across the bottom of like a mangrove, and they're systematically feeding on the sort of microalgae and other nutrients from the sand. And the video shows them in maybe not a line, but definitely in a kind of pattern marching across the bottom. And there are other aspects of, I've talked about other sea star behavior, in terms of predation and other sea stars that feed on things. And then right now, because of so much videography and additional photography going on in the world, we have things like, well, for example, in reproduction, sea stars are what's called broadcast spawners. They release the males and the females release the eggs and the sperm into the water. But what hasn't really been well documented is the fact that some sea stars will actually raise themselves up on their tippy toes. And it sounds bizarre, but they do this. But they will go from that sort of flat, splayed pose behavior that they have, and they will literally kind of hoist themselves up. And this is weird enough to see some 5-rayed animal doing this. But when you see, like, there's a sea star in the tropical Pacific that is called Luidia, and it has like anywhere between 8 and 12 rays, and it's about almost a foot and a half across, and when you see even the pictures of these things just rearing themselves up, and then, in order to spawn, I can't imagine what that must be like seeing it when you're there. The pictures are bizarre enough, but that's what I'm saying is that we're now seeing so much because we're doing so much more investigation and we have access to many more of habitat and seeing how they live. My rating is high because there's still so many surprises left to go. And then I should follow up and just say that the reason they do that is because the spawning gametes have to get into the water current so that they can meet other eggs or sperm. And so getting away from the bottom is imperative in some species. It helps those reproductive products meet because the water currents are higher farther up into the water column. So like sometimes there could be very poor water current flow sort of near the bottom, there could be more drag or what have you. But, by getting themselves up on their tippy toes, they get all of that sort of more up into the water where there's less drag. So in other words, when water is adjacent to the bottom, it literally drags a little because the bottom kind of creates a friction. The farther up into the water away from the bottom, the more powerful it is.
That's pretty clever.
Well, I mean, there's all sorts of weird things, clever things that that animals do that you can't learn that from specimens in a drawer. And even I am, even though I don't go into the field much, I'm putting all of this together. I mean, in a way, I'm a classic DC analyst. But a lot of what I've been doing lately is piecing together mysteries from photos, videos, and pictures, and the literature. So it's been very interesting.
I bet. Are sea stars able to learn new things? Like, what is their learning capacity like? If you give a sea star a new situation, are they very adaptable to that?
Again, the thing about it is that they're really hard to read in that sense because they're pentameral. They don't have a head. And so they're likely to move. I mean, there is some evidence that they can pick up on avoidance. Like if you shine a light at them, or if you hurt them, or if you have some stimulus, they will react to that. Like some sea stars, like I said, the crown of thorns that have eyes, so to speak, they will move towards coral, and they can smell the coral on top of that. But purely for the sake of just can you teach them to do tricks? I don't know that they're built that way. Like they can be trained, certainly, because I can't tell you how many times in aquaria, like I said, you drop a whole bunch of, we used to have what was called a krill milkshake. You take a whole bunch of shrimp and you shred it up in a blender with nutrients and such, and you throw it into the water, and it's great food for sea anemones and such. But the nutrients are so rich in the water that everything reacts. And sea stars start to just, at a certain point, their behavior becomes fairly stereotyped relative to the stimulus. I'm not sure if it happens if they can react at the same time every day. I mean, I have done experiments where you flip them over, and and some of them have what's called a leading arm, and sometimes it's actually a distinct arm as opposed to just like a random arm. But are they capable of more than that? Can they run a maze? That sort of thing. I mean, to be honest, off the top of my head, I don't think of anything like that as having been shown. It's possible they have, but it's at the very least a very poorly known part of their biology because, well, it's hard enough to show intelligence. I mean, octopuses, for example, show a lot of intelligence because they do a lot of things that we would interpret as intelligent. But sea stars are so alien that, I mean, they have no head, they have no ganglia, they have no brains. The eyes aren't, where we would put them, so to speak. Their body morphology, the shape of the body is just so different that, if you were to ask me, can they learn? My answer would probably be, Glorbazorp. I don't know. I mean, it's hard to say,
Sure.
I guess I would say probably not, but I don't know. Maybe they can. And there's papers that have better documented it. But it wouldn't seem like something that they do well.
They're doing everything else on a stretched out timeline, right? We're kind of living a little too fast for them.
Oh, and that's a good point, of course, right? Because, watching them flip, I mean, I did this for a whole summer where it was one of my earlier student projects where I would just watch sea stars turn themselves over. And I mean, even for relatively fast animals, we're talking, each animal is like 5 minutes at a time, and getting beyond that, getting into time lapse and watching anything significant would be, and watching time lapse is fun. Filming time lapse, I mean, if anything, it's more of a behavioral test of the researcher than the animal, because you have to sit there and kind of make sure that everything's going smoothly and that you didn't forget to hit the right button. Because I've done that, you just run several tries and you come back and you're just like, oh crap,
That was a practice run, I guess.
I forgot that. Yeah, forgot to do that. So in one sense, to be honest, I do see something there that shows complexity and even, I dare say, curiosity, because I've seen time lapse video when you put a whole bunch of sea stars into a tank that they haven't been in before, and they go roaming around, and they literally will go exploring and sort of like moving in time lapse over every surface of the tank that they're in. And my interpretation of that might be curiosity, just to see what's going on. What are they walking over? Where are they now? What are they doing?
Getting the lay of the land.
Yeah. And one assumption one might make is that if they had the relative intelligence of a stump, that they would just sit there, until it was time to eat. And I'd say that because they spread themselves out, they will go exploring. They'll do a lot of things like that. So there's something, but I couldn't tell you how much of it there is. It's just that in science, behavior is really hard. It's very difficult to toe the line between what is an observation and an interpretation.
Mm-hmm.
And it's easier if you have like a bilateral animal, something with a head with two eyes, and you have at least a certain familiarity, what it's doing. I mean, because we all have two eyes and bilateral symmetry, but you get into something like this and you're just like, I don't know, is exploring? Is that just natural? I mean, what is it doing? So it's fascinating, but it can be, and if someone out there was going to pay me all day to just explore starfish behavior and to just watch time-lapse videos of different sea stars all day, I would love to do that. But unfortunately, there are lots of other priorities, and there's always opportunities to learn about different species doing this. And that's always fun to discover. But like I said, when you get into the nitty gritty of it's surprisingly more difficult than it sounds. So
Sure. That makes sense. Well, so ingenuity is one that's a little bit like, where do I go with this one? Our last category is a little bit of a softball, though. It's like, okay. It's a softer throw. So the last category is aesthetics, and it's purely your completely biased, arbitrary opinion. and I know, we're talking about so many different sea stars, but in general, what would you give the sea stars for aesthetics?
Oh, that's definitely a 10.
Right?
Or higher. Well, the thing is about echinoderms in general is that so many echinoderms get high ratings because they're so weird. If I was being relative to other echinoderms, don't tell any of my brittle star colleagues this, but brittle stars are related to sea stars, and they often have really just bizarre patterns and skeletal shapes that I really love.
Are these the skinny ones?
Yeah. So they're relatives of sea stars that have a sort of more truncated, the arms are like basket stars, and they're relatives with long skinny arms, and they're very fragile. But when you get into the intense details, brittle stars have even more bizarre patterns. But sea stars also have, patterns that I could go on and on about because, well, like I said, some sea stars are the group that I studied for my PhD, the Goniastridae. They're collectively known by some people as the cookie stars because there's a bunch of them that are basically shaped. They're almost entirely pentagonal, and all of the plates that make up their body are in really ordered linear patterns. And they're just beautiful because the patterns are so distinct and the plates are so organized. But I can tell you that there are also just things that we've seen in the deep sea that I've never seen before. Sea stars that there was a sea star that I was just working on the other day called Coronaster, and it's a 12-armed sea star, but it lives in a jumble. It's orange and it has spines. And we didn't know this until we saw them alive, but they live in a big jumbled pile. And so when we actually saw them, we didn't immediately recognize them because typically when I see the specimens, they're all splayed out. But this one had all of its arms kind of folded back on itself like a bramble. And it was just this bright orange color. And so, you're going along the deep sea floor and it's black or brown or whatever. And you see this bright orange bramble with all of these spines coming off of it. So there's geometry, there's color, there's all sorts of just bizarre patterns. The sea star that I told you about that got made into a toy, the common name I've started referring to it is a pumpkin star because it's about a foot across. It's bright orange and it's about 6 inches thick. And, and the texture, the animal's texture is actually like the flesh of a pumpkin.
I wonder when we'll start to see like little statues of them as like Halloween decorations.
It does remind me to start pumping that out on Twitter again, though. No, but we've also seen with the advent of more submersibles in mesophotic, it lives in the mesophotic zone, just above the deep sea, but just below coral reefs. And so some of them turn out to be red with mottled patterns. And so, it turns out to be quite pretty. So, I mean, it was pretty before, but it comes in more than one color, basically. So like I said, there are some sea stars that are ball shaped. Some sea stars are cookie shaped. Some of them have long arms that make them look like living snowshoes. There's literally like some sea stars that have arms that are elongate and they taper out, but they're hard. I mean, they're not just like spindly. They're actually like long prongs that come off of them. Like I said, there's a lot of patterns on the disc, and there's oftentimes a lot of sea stars with different kinds of what would be called ornamentation, plates modified into different shapes, little table type things, spines, you name it. But really all echinoderms have these kinds of qualities. I mean, a lot of what I love about marine invertebrates is there's just so much weird stuff. There's so many interesting animals to look at. And if I ever got tired of sea stars, I could always move on to brittle stars or crabs or mollusks or something. There's just so much diverse stuff that's so beautiful in nature. And, and I think people forget how much of it is beautiful until and that's why I think we live in a kind of a golden age now, because so much social media brings photographs, especially on Facebook, streaming video from Okeanos. Everyone can see the deep sea now, but even with the coral reef, people who swim in sort of pelagic blackwater habitats, divers bring hundreds of photos, thousands of photographs to Facebook to just share. And so, people can now see an endless number of jellies and fishes and what have you. Anyway, the color also is very useful because it puts so much of their biology into context. Some of the speckled patterns that I'm watching look like they might be used for camouflage, because they're often hiding on rocks. There's this one sea star that lives across the Indo-Pacific called Answeropoda, colloquially known as a carpet star. It's so thin that it looks like a piece of cloth draped on the bottom of the seafloor. You can literally pick it up. It's like a piece of parchment or paper. And, and I'd never seen one alive before. It's red with speckled patterns, and they live on sandy bottoms. So, presumably that's to help them blend in. I can't tell you how many rare sea stars that I've looked at countless times, but thanks to Okeanos Explorer, we would see it alive and in its living habitat. And, and it would just be orange or something, or white or something, but it would be like, wow, okay, now I know what that looks like alive. And surprisingly, that's an important fact that I find important. And, just the geometry of the animals, because there's certain groups that, like I said, the goniasterids, where if you look at them really close, the plate patterns almost have they're almost dome shaped sometimes. And they take on a real, almost a sculpted geometry. It's fascinating. And then if you get into the microanatomy, you're looking at things like those little claws that I talked about, the bear traps on the sea star from Antarctica. When you look at those up close, they're terrifying because they look like jaws. I mean, they're just these big toothy, blades. Those little bear traps are called pedicelaria. Most sea stars have them. But when you look at them under special microscopes, they have a lot of bizarre and fascinating details. Some of them have teeth. Some of them are just big lips, sort of lip-shaped things. So, there's a whole new universe of aesthetic when you get into these micro scale details. It's like that Powers of 10 video that everyone used to watch. And it's on YouTube, but everyone used to watch this on public school. You go through different levels of magnification, and you go from seeing the whole animal to a whole bunch of animals to the animal on the surface to micro scale. And there's multiple levels.
And it's beautiful every step of the way.
But yeah, I've had my colleagues bring me in to do lab and lectures on sea stars and echinoderms, and I think every one of those students regrets the fact that I can speak for almost 2 hours.
I feel like if I just had infinite time, I could just sit for like hundreds of years and just ask 100,000 random questions about sea stars. And then it just makes me be like, I should just go out and see some.
Well, one of the things that I've done for other podcasters also is if you ever come up to DC, please do come up to the Smithsonian when we're open again. And you could probably almost do a podcast just on but to walk through the department museum and show you what kind of place I work in.
Oh yeah, I'd make a trip for that.
So again, when the world is back to normal, I look forward to giving you a tour.
Oh, amazing. Well, before I let you go for today, so first of all, thank you so much for all of your time and knowledge. I just wanted to let you take a second to, let people know where they can find your work, what kind of stuff you're working on now, anything that you want people to know about.
Certainly. Well, my main sort of venue nowadays is my Twitter account, and that's at Echinoblog. So like Echinoderm, except with a blog, ECHINOBLOG, or just look me up on Twitter. I'm not difficult to find. That corresponds to the blog that I wrote. It's been somewhat quiescent over the last several years because I've just gotten busier, and frankly, I've found Twitter to be sort of more short-term effective. For the moment, I have any number of publications that, I publish about 4 a year, but otherwise I can simply be found, there's a whole bunch of things on my blog and on YouTube where I show up. I'm often on Okeanos Explorer, which will hopefully return in 2021. You can hear my voice chime in on the phone if you're doing the deep sea dives. But for now, I hope I lived up to expectation, and I'm happy to take questions when you have them via Twitter or what have you in the future.
Awesome. Well, thank you so much for your wealth of knowledge. I feel like I have a much deeper appreciation for sea stars now, and I'm going to carry that forth. And probably everybody that I ever am at a party with for the rest of my life is probably going to be cursing your name, because that's definitely going to be my go-to, like, let me tell you this about sea stars.
Well, I'm also happy to satisfy the curiosity of a young viewer, and coincidentally, my brother lives there in Colorado, near Boulder. So I hope she is satisfied with the picture of sea stars that I've painted.
Well, thank you so much. I will release you back into your life, and we will talk to you later.
It's a pleasure. I'll talk to you in the future. Thank you.
Thanks. Bye.